Welcome to Lean IT Foundations Training. In today's session, we will be going over Section 1C, Continuous Improvement, Lean versus Six Sigma. This is an optional course. Section 1C, Lean versus Six Sigma. I am your speaker, Anthony McCollum, and I am a Process Improvement Specialist. Today we'll be talking about Lean versus Six Sigma. Lean and Six Sigma are terms that you have probably been hearing quite a bit lately. There is a difference between the two, and the point of this session is to talk to you about the similarities and the differences between these two terms. Both Lean and Six Sigma are both approaches to process improvement. Both Lean and Six Sigma are customer-focused. Everything we are doing in these process improvement methodologies is geared towards improving the entire customer experience. Here we find our first difference. Lean is focused on value creation for the customer, while Six Sigma is focused on reducing defects at each step or specific steps within the process. Lean is focused on the process flow, identifying and finding waste within the process steps and driving that waste out of the process. Six Sigma focuses on data, data-based decisions when it comes to problem solving. Lean focuses on increasing the speed at which a product or service is delivered to the customer, while Six Sigma is focused on the quality throughout the entire production or service process. In order for Lean to work within an organization, the entire culture of the whole organization needs to start believing and thinking in a Lean mindset, whereas Six Sigma is a team-based approach to problem solving, where a specific team will identify one particular problem and use data to drive out defects and improve quality. Again, where these two things come into relationship with each other is they both seek to reduce variability in the process. Here's the 6 ingredients of Six Sigma. Again, genuine focus on the customer, right? Everything we're doing with a Six Sigma process improvement project is geared towards improving that customer value. Six Sigma makes fact-based decisions based on the data that they find within the process or data set. Six Sigma does focus on the process, but again, it's using that data to make decisions on where to implement the improvement steps. Six Sigma uses data, again, to proactively manage potential problems within the value stream. Based on the data that we collect, we should be able to anticipate when and how often a problem will occur. In order for Six Sigma projects to work, the Six Sigma team must be able to move across boundaries within the organization. If there are silos in an organization preventing a Six Sigma team to implement their improvements, a Six Sigma process improvement project will not work. And in the end, Six Sigma is driving towards perfection. Let's take a look at what we mean by that term perfection. To do that, we'll start off with defining what on earth Six Sigma is. Well, Six Sigma is really made up of two things, an average and a standard deviation. These are the two things we need for a Six Sigma-based process improvement project, an average and a standard deviation. Let's talk about this thing in this average. What is an average? An average is sort of just the most typical response that we get in a set of data. To simplify that a little bit, we work on averages in our everyday life. On average, how long does it take me to drive to work? On average, how many customers will call in today? On average, how many smoothies will I sell today? These are the types of averages that we're talking about when we're taking on a Six Sigma-based project. Well, what's a standard deviation? Well, the term sigma is a standard deviation, right? So those two words mean the exact same thing. Six, standard deviation, six, sigma, same thing. But what is a standard deviation? Well, let's take our driving to work example. Let's say on average, it takes 45 minutes to drive to work, give or take 5 minutes. When someone says give or take, around about 5 minutes, that's the standard deviation. On average today, we're going to get 100 phone calls, give or take 10 phone calls. Again, that give or take is the average. That's what we're talking about, or is the standard deviation. That's what we're talking about when we are saying give or take. So let's take a look at our drive to work example and see if we can make some sense of these averages and standard deviations. Note the numbers at the bottom of the screen that fall under the bell curve. Now, we may remember this bell curve from high school. Don't worry, this will not be too heavy in mathematics. So we take a look and we see in the very center, we have our average, 45 minutes. That's how long it takes me to drive to work. It takes me 45 minutes to drive to work, give or take 5 minutes. What does that mean? Well, statistically, if it's an average of 45 with a standard deviation of 5 minutes, 68% of the time, you will arrive to work between 40 and 50 minutes within 1 sigma of your average. Note that the sigma, or the standard deviation, is both on the positive and negative side of your average. Let's expand on that. If on average it takes 45 minutes to drive to work, give or take 5 minutes, what we're saying is 95% of the time you will arrive to work between 35 and 55 minutes, or within 2 standard deviations of your average. This same logic applies if we go all the way out to 6 sigma at the very end of our bell curve. If we are saying with 6 sigma confidence that our average drive to work is 45 minutes, give or take 5 minutes, what we are saying statistically is that 99.9997% of the time you drive to work, you will arrive to work between 15 and 75 minutes. Now, how do we get our average and our standard deviations? What makes these things up? Well, you're generally going to get this data from a population set of data. Now, whether this is data that has been provided to you in Excel, or whether this is data that you have to go out and collect, there's going to be a population of data, a world of data on the particular thing that you are studying or the particular process that you are trying to improve. Everything that happens within that improvement project is your population set of data. Now, let's say, for example, that this population set of data is made up of 15,000 blue triangles, 10,000 orange circles, 4,000 gray squares, and 1,000 happy faces, for a total of 30,000 shapes. Now, again, this is a conceptual population set of data, but this can be types of phone calls received, or types of smoothies served, or types of customers that arrive. These can also be service times. These shapes are representative of whatever your population set is made up of. Now, if you don't have data and you have to go out and collect data, it may be a daunting task to think of everything that you need to go and do and study and record. But fortunately, because of statistics, we do not have to go out and collect every single data set. In fact, all we have to do is go out and collect about 30 random samples. So if we were, for example, to reach into this population set of data made up of our shapes with a blindfold and randomly pull out a shape, 50% of the time we would pull out a blue triangle. Again, blue triangles make up 50% of our data. If we look to the left, there's 15,000 blue triangles out of 30,000 shapes, which is why 50% of the time, if we sample our population data, we'll pull out a blue triangle. 33% of the time, we'll pull out an orange circle. 13% of the time, a gray square, and 3% of the time, a green happy face. Now, we do have a definition here, and that definition is rarity. When we're taking on a process improvement project, we do not want to focus on things that rarely happen, but it's important for us to define what rare means. Statistically, if an event occurs less than 5% of the time, it is a rare occurrence. When we're taking on process improvement project, we don't want to tackle these rare things first. You know, these rare things may be, you know, things that can really annoy or bug the people doing the job. But we want to spend our time on things that are more occurring in the population data set. So we want to stay away from those rare things. Two things to note. First, if you are going to sample, your samples have to be random. You cannot base your samples around when it's convenient for you to go ahead and take a sample. Again, they have to be random times of the day, random sets of customers, random days of the week, possibly even random months, depending on the type of data that you are taking on. Now, I'd like to take a second here and talk about the place where Lean and Six Sigma meet. In section 1, we talked a lot about waste in process. We noted how variability creates waste. In this section, we're talking a lot about Six Sigma and how Six Sigma is really focused on quality. And these are sort of those areas where Lean and Six Sigma really start to converge. And these are the types of reasons we hear these two terms, these two process improvement approaches brought up together quite a bit. To understand where Lean and Six Sigma meet, what we're going to do is take a look at our dartboard. Now, what we're looking at here is a sample of high variation with low quality. If you're taking on a project, odds are there's a process that may be in place already that, for whatever reason, has waste within that process, a lot of variation creating that waste. And we may be getting inaccurate quality as a result. When we take on our project, a lot of companies start with Lean first before they move on to Six Sigma. What Lean will do is it'll help us lower the amount of variability within that process, right? We're starting to dial in what we are trying to work on, but we still may not be getting the particular type of quality we are looking for. Once we bring in the statistics, the data-driven approach that Six Sigma brings to this, that's when we really start to zone in on the low variability and accurate quality that we are seeking to achieve. And once we truly dial in that Six Sigma, again, we will do the exact same thing, the exact same way, 99.9997% of the time. And from a Lean perspective, we've nailed Tim Woods. If you'd like to learn more about the Six Sigma process and Lean methodologies, The Six Sigma Way is a great book to pick up and read a little bit more about the Six Sigma process. The Six Sigma Way defines process improvement as a strategy of finding solutions to eliminate the root cause of performance problems in operations that already exist. It seeks to fix the problems of eliminating variation while leaving the basic system intact. Let's do a little quick knowledge check here. Which is not an objective of Six Sigma? A, statistical analysis, B, problem solving, C, behavioral change, or D, the reduction of variability. And the answer is C. Six Sigma, again, is a team-based approach on problem solving, whereas Lean really requires the entire culture of the company, right? Cultural or behavioral environment that we are working in to buy into the process that we are trying to improve. This completes section 1C, Lean versus Six Sigma. Thank you.